Forward. So I just presented this schedule. Today is October 12th. It's Wednesday, and we will be doing review. So that way we could record it for next time that we meet in person. If you have any questions, you can then address them there. And then we'll have the midterm on Wednesday, the 19th of October. It will be 2 hours. And we will be starting with the last topic before the midterm. The last two topics would be a continuation on transformations, which has to do with the homework, and inverse. So last time we spoke about transformations for a parabola, and we said that a function is f of x is equal to x squared, whereby if we use the vertex form of the equation, the vertex form of the equation gives us transformations for this parabola. H would give us horizontal movement, meaning that it's going to move left and right. And K would tell us that it's going to go up or down, right? We always take the opposite value of H. So if our parabola has changed and now we have some transformations and we have x minus 2 squared plus 3, what would be my H and what would be my K value here, ladies and gentlemen? Anybody? Nobody? Nobody?
X, the H
Yep.
would be X, and the K would be 3.
Would be Y, and this would be 3.
Y.
And what would be the
Yeah.
H?
The H would be the X, the 2 minus 2.
It would be positive 2.
Oh,
You take
yeah,
the
that's
opposite.
right.
Yeah, always the opposite value. Don't fall for it. And this
Oh, boy.
point here would be our vertex, right? No, it's good. I'm glad you're practicing. I'd rather you do it here and not on the midterm. So my vertex here would be 2, 3. And what would be my axis of symmetry? My axis of symmetry is an equation, right? Which would be x is equal to something here. And that x is equal to something would be x is equal to what value? X is equal to 2. So if I draw this and I put my vertex, that would be 2, and then this is 3. I know I have a positive parabola because it's positive, right? Right here.
Yeah.
This value here is positive. So I know this parabola is going to look this way. My axis of symmetry, I said, was x is equal to what? X is equal to 2. This would be my axis of symmetry. And then the next question would be, what's my domain and what's my range? Now, if you recall, x is represented for domain and y is range. X is left and right, range is up and down. So for domain, what would be my values for domain if I write this in interval notation?
2.
This would be negative infinity to positive infinity for domain. And then my range, if I look at my vertex here is 2, 3. And if this is x and this is y, my y is 3. So if my lowest value for y is 3, right here, this would be 3 bracket 2. Where is this pointing to? To infinity. So this is positive infinity. So this would be my range. This is my domain. Remember, domain is x values. So where is the function going? It's going all the way to the left and it's going all the way to the right. Range is up and down. The lowest value for range for in this case would be my vertex because it is a positive parabola, and that value would be 3 for y. So that is why I get 3 here. And where am I going? I'm going up. Where? Positive infinity. So this is transformations for a parabola. But if you look at the homework that's coming up, that it's going to be due next week, Monday, which I'm about to present to you, you're going to see some functions that are not parabolas.
Professor, I'm sorry. Can I make a quick question?
Sure.
Isn't the 2 part of the interval like, for the domain? Like the 3 is for the range?
Yeah, the 2 is part of the, is included in the interval for domain, but we're
So
not
we-
gonna say negative infinity to 2 and then
Okay.
2 to positive infinity. And I'll give you a scenario. You're taking JetBlue to Miami or Orlando. Let's say you're visiting Mickey Mouse. The pilot is always going to say, this is a flight from New York to Orlando. And the pilot is not going to say, right now we're flying over Washington, DC. Right now we're flying over Georgia. Right now we're flying over South Carolina. Right now we're flying over North Carolina or something like that. So the same thing is here. If the 2 is included within your interval, you're not going to mention it because it's part of the negative infinity to positive infinity. If the parabola is not continuous, and let's say is a stop, which I showed an example of, then we would have to then say, okay, it stops here. But in this case, for the parabola, that would not be the case. But I'm glad you're mentioning it because if you have that question, I know others may have it. So thank you for sharing.
Thank you.
I appreciate it. Okay, so if everybody sees the homework here, this is what's due next week, Monday. You see that, well, let's see if I can zoom in on this. We have x to the 3rd, right? And then they're adding a 6 to it. So we're going to be talking about that today. So I'm going to be going over that. Then they're also showing what happens to a parabola here. What's going on with this parabola? This is part of the midterm. Is this a positive parabola or a negative parabola? Anybody? What does that negative mean in front of the function? I guess that Columbus Day off really messed up everybody's brain.
Say negative.
Right. So this is a negative parabola. So what would be my vertex here for this problem?
Negative.
What would be my vertex? This is what? What would be that? What's the value of my vertex? Anybody?
Can I ask a question?
Sure.
Can't you just can you plug in any number in to find the
vertex?
Yes.
No, you can't do that because you have to derive it from this h value. And that h value here would be -3. What is my k value outside?
1.
Look at it outside. What's here? This is k.
0.
This is 0. So my vertex here is 3, 0, -3, 0 to be exact. So I go here, -3, 0. And since this is not a positive parabola, and that's my vertex, where is this going to go?
It's gonna go upside down, so down.
That's that. It's going to go this way. Now, this is a rough sketch, but like the gentleman was saying, you could use values for other points, such as your x-intercept or your y-intercept. But for your vertex, you truly got to look at the equation. X-intercepts and y-intercepts, you can use points. But for the vertex, you truly got to look at this equation and really see what's going on. All right, so I'm going to clear this out because this is just a continuation of what we had before. And we also we're going to go over the square root, what happens to it, what happened to the square root, what happened to this square root, what happened to this square root. So we'll be going over that as well. And then we'll be discussing odd, even, or neither, which is not that complicated. It looks complicated, but it's not. And here we have an absolute value that has been moved to the right 3 units, down 2 units, to the left 3 units, down 2 units, to the right 2 units, up 3 units, to the left 2 units, and up 3 units. But here, they want to know this graph on the right-hand side, which one of these 4 matches it. So based on this graph, if this graph has an X value that moved to the left and it went up 3 units, so you know that by process of elimination, the first 2 answers are wrong because the K value here is -2. And here the K value for this graph is what? It's going to be 3, right? So if my K value is 3 here, it cannot be -2. So these 2 are out. The problem I have now is which one is it? Is it X -2 or X +2? Being that the graph moved to the left 2 units.
It's
And the
+2.
answer is going to be +2 because you always take the opposite value of the H. So the opposite value of H would be -2 and this would remain 3. So my answer here would be the last one. There you go. That's your answer. It's not hard. We'll go over this. So I'm going to share my my iPad right now. So that way we could do these on the iPad. So we just showed transformations for the parabola. But as you can see in the homework, they're now going to be introducing x to the third. They're also going to be showing square root of x. And they also gave us a sneak peek of the absolute value. So the same thing applies as with the parabola. So you're going to have x minus h, but this time to the third plus k. This is you're going to have the square root of x minus h plus k outside. And then for the absolute value, it's x minus h plus k. It's not complicated because the same rules apply. Being that the same rules apply, then you know that you're always going to take the opposite value of your h value and your k will remain the same. So in the example that they were giving us in the homework and the one that I was just showing you, they had x plus 6 to the third. So what does that mean? What's my h value here for this problem? My h here is what? My h here is -6. What's my k value? What's outside here?
1.
0.
0. Correct. So this is going to be -6, 0. So how do I graph this? Well, I got to create my x and my y axis. And then I am going to then go to -6, 0, 1, 2, 3, 4, 5, 6. And what type of function do I have? Well, if I'm taking you to the zoo and I'm showing you an elephant, does an elephant look like a giraffe? No, it does not. So we need to know what these are. This is a cubic function. The one we just did before, prior to the cubic function, this is a parabola, right? Or a quadratic function. So what does this look like? If I graph it, it should look something like this, right? Doesn't it? Like that, like a spaghetti Statue of Liberty? There you go. So I'm going to come here at -6 and I'm going to draw it. Is this exact? No, it is not exact. It's an approximate answer, but I'm trying to understand the difference between a giraffe and an elephant and a monkey, right? Or a gorilla or a chimpanzee. They're all different, right? So right here, the square root of x, f of x is equal to the square root of x. What does that look like if I graph it? Last time I checked, when I graphed it, and I know there's a video and hopefully you guys are watching it, it looked like this. It looked like the Nike swoosh. So in the example that they had in the homework, they had in the homework, f of x is equal to the square root of x. F of x is equal to the negative square root of x. And f of x is equal to the square root of -x. So we're going to go over all of these. So I know that square root of x, since there's no movement there, is gonna look this way. Right? Because that's how it looks like. If I do a table and I put the values there, I put 0, I put 1, I put 2, I put 3, I put 4, I'm gonna get those values. And then I'm gonna fill them in. And when I fill them in for the y values, I'm gonna get what you see in green. But what happens when there's a negative in front of your function? Well, guess what? All these values are gonna go. They're gonna get reflected. Over what axis? Over the x-axis. Just like in the parabola. In the parabola, when we had a negative in front of the parabola, it flipped over, right? In this parabola up here, minus 2 plus 3, if I had x minus 2 plus 3, but there's a negative here, then this parabola is going to go to the right 2 units, up 3 units right here. But guess what? Instead of pointing up, it's going to be pointing down. Why? Because I have a negative in front of my function. It's going to go down. My axis of symmetry is still the same. X is equal to 2. What's my vertex? 2, 3. We did this before, but this is now a negative. So the same thing here. It's being reflected over the x-axis. This here is being reflected over the x-axis. Now, what happens when you negate the x inside the function? Whenever you have something like that, you're being reflected over the y-axis. Over the y-axis. And you got to look at your original function. This is your original function here on the left. Or the he nodded, original function. So your original function is in quadrant 1. If it gets reflected over the x-axis, it ends up in quadrant 4. Right? But if it gets reflected over the y-axis, it ends up in quadrant 2. This is quadrant 2. So those are the questions on the homework that talk about the square root, that talk about cubic function, cubic function. And then this brings us to the next topic of the absolute value. So for the absolute value, we have f of x is equal to the absolute value of x. And we know if we graph this, it's going to look something like this. Right? But if we have movement for this function, such as in the example that we had for the homework that I just showed you, that was the example that they gave us. They actually gave us the graph. So the graph they gave us was this. That's the graph they gave. And then they said, which of the 4 formulas does it apply to? And this is the one, x plus 2 plus 3, because this would be -2, +3. Now, in an absolute value function, what would be my axis of symmetry here? What is that imaginary line that if I put it smack in the middle of the function, it's gonna, right, correct. I would be putting an imaginary parallel y axis there. But in order for me to do that, what's the formula that I have to use? Like, what's the equation? Is it going to be y is equal to something, or is it going to be x is equal to something?
Y is equal to K.
No. So right here, what's my x value here?
-2.
Right. Remember that in order for me to create a vertical line, let's say I'm creating a vertical line here at 4. This vertical line is x is equal to 4. So this vertical line here is x is equal to -2,
Oh.
right? So
Oh.
we have to be very careful because when they say, what is that axis of symmetry? What is the equation for the axis of symmetry for an absolute value? Is very similar to what is the axis of symmetry for a parabola? Because parabolas and absolute values are symmetrical over the, what axis is this?
X equals -2.
No, what axis? Axis.
Y-axis.
Y-axis. So you have to understand those concepts. Y symmetry is like the butterfly, right? Your eyes, your ears, your arms. What do you have on the left? You have on the right. But in order for you to cut yourself in half, or in order for you to cut the function in half, you have to have an equation that is x is equal to something. And what is that equation? It's going to be x is equal to -2 when it comes to this absolute value. When it comes to this parabola, it's going to be x is equal to -2. I'm sorry, here it's x is equal to 2 because my vertex is 2, 3. This is my vertex. My vertex is 2, 3. The absolute value also has a vertex, which in this case is -2, 3. But I know it's confusing. This is quadrant 1, right? Where is this? This is in quadrant 2. All right. You gotta differentiate these. You gotta familiarize yourself with these functions. Okay, so that leads us to understanding not only the graph, but the properties of the graph. So let's do a square root. So square root of x, right? It's like that, right? If I have a square root of x that has moved, what would be my starting point? Excuse me. What's my starting point? What's my h? What's my k?
3.
The K is the +3.
K always remains the same.
It's just the H is
The h is always the opposite value.
0.
So this is h, this is k. So what would I put here for k? Would I put 0 or would I put -3?
-3.
-3. What would I put for h? I take the opposite value of h, which is what?
-3.
There you go. So my starting point here for h and k is going to be -3, -3. So it'd be 1, 2, 3, 1, 2, 3. I have to then ask myself, is this parabola positive or negative? And the parabola is not parabola. Square root of x. What is this? It is the square root, right? I have to ask myself, is this square root positive or negative? And the answer is, what's outside here? It's positive. Unless it's given a negative, it's always positive. And how do I graph this? It's gonna look like that in the orange. So this is how you graph a square root of a square root that has an h and k of -3, 3. So what would be my domain here for this problem? What's my domain? Look at the
Negative
X value.
3 to positive infinity.
There you go. That's correct. Because this value here is -3. That's for my X axis, right? Remember, domain are all X values. So it's gonna go from -3 to positive infinity. What about range? What does range represent? Range represents Y values. So what's the low? So what is this point here? This point here is -3, -3. This is X and this is Y. So what do you think my range is gonna be?
-3 to positive infinity.
There you go. Because these range are all the Y values. While the X is all my X values. And remember, X is left and right, left and right. Y values are up and down. Look at the Y values, up and down, like an elevator. Like an elevator. So let's do a little recap. So we started off with a parabola, X squared. It had a vertex. And then we said, well, guess what? For the homework, we're gonna be introducing the other functions, which we are already previously introduced. I know, because I saw the videos. And this is cubic function. Then we have square root and we have absolute value. And they have the same characteristics for H and K. For H is the opposite value. H is left and right. K is up and down. Domain are X values, range is Y values. What's the axis of symmetry? So let me ask you this. What type of symmetry does a square root of X have? I know I went over this. It's in the recording. It was in, let's see, what recording was that? Trying to remember. I think it was the recording on October 3rd. Nobody remembers? Okay. This has no symmetry. No symmetry. Are there X values here? Reflected over the Y axis? No. Are there values here reflected over the X axis? No. Are there values here reflected over the origin? No. So the square root of X does not have symmetry. What type of symmetry does the absolute value have? It has Y symmetry. What type of symmetry does a parabola have? Y symmetry. What type of symmetry does cubic function have? Where is it? Where's my cubic function? Right here. What type of symmetry does this graph have? Over here.
This is an X.
This is origin symmetry. And I know this is not the first time I went over this. All of this is gonna be on your midterm. You got plenty of time to watch the videos. All right, let's continue. So you also need to understand even, odd, or neither. So what is this? Even, odd, or neither? Well, in order for us to test whether the function is even, we have to get ourselves back. Get the same function back. For an odd, you get the negation of your equation. And neither means none apply, right? You're not gonna get yourself back and you're not gonna get the negation. All right, so let's prove the let's let's put the metal to the test, right? So I have a function, which is x squared. And how do I test for this? Well, I'm gonna put a negative value inside my x value. So what negative value am I gonna put? I'm gonna put a negative x. I'm gonna replace x with negative x. If I do that, it's like x times negative x, right? Negative x times negative x gives me what? Positive x squared, right? Did
Yes.
I get myself back?
Yes.
And this is even. If you get your equation back, you're even. Now, let's do a different problem. F of x is equal to x to the third. We're gonna do the same thing we just did. F of x, we're gonna put our parentheses here. And what are we gonna put instead of x? We're gonna put negative x. So negative x times negative x times negative x gives me what? A negative and a negative gives me a positive. A positive and a negative gives me a negative. Did I get the negation of my function? I sure did. I got the negation. It's no longer I didn't get myself back. If I would have gotten myself back, it would have been positive x to the third. I got the negation. It's like multiplying a -1 into it. So this is odd. All right, now let's do the opposite. F of x is equal to x squared plus 2x. Let's try that. So if I get myself back, then I should get x squared plus 2x, right? Then I am even. If I get the negation, then I'm odd. What's the negation? The negation is negative x squared minus 2x, right? You guys understand this? If I don't get neither of these two, then none of these apply. That means I'm neither or neither. So let's see which one it is. So I'm gonna replace x with what? With negative x. So then I'm gonna get what? I'm gonna get x squared. And then here, I'm gonna get what? Negative x. So I'm gonna get negative 2x. Is x squared minus 2x the same as x squared plus 2x? Is it?
No,
No. Is x squared minus 2x the same thing as the negation, which is negative x squared minus 2x? No. No, so this is neither. So by me replacing the x's with negative x's and then testing it out, if I didn't get myself back, then I'm not even. If I didn't get the negation of the equation, then I'm not odd. I got something totally different, so I'm neither. All right, cool. All right, let's continue. All right, so then this brings us to the inverse. What is inverse? I'm glad you asked. I'm glad you asked. Let me show you on the screen. All right. Google. Everybody know Superman? Does everybody know Superman?
Yeah.
All right, so this is the Man of Steel. This is our main function. This is the Big Mac Daddy, right? This is a Superman function. So the Superman function is pretty cool because it's a regular function. But then Superman has an inverse to him. Oh, I misspelled his name. Bizarro. So Bizarro, this guy right here, he has the same powers of Superman. And he has the same weaknesses, meaning that kryptonite can kill him. The problem with Bizarro is not very smart. He lacks the intelligence that Mr. Superman, the regular guy, has. So why do I bring this guy up? Because this guy's the inverse to Superman. And I'm going to show you what that means mathematically. So now let's share my iPad. And I'm going to show you what the inverse looks like. Now, another way of explaining inverse, how many of you have a mirror in the bathroom? Everybody should be saying, yeah, I got a mirror in the bathroom. When you are looking at the mirror, you are the function. You are the main function. The reflection that's looking back at you in the mirror is your inverse to you. And if that gets more complicated, let me give you a mathematical.
Professor, but isn't inverse upside down? Like if it comes to a fraction, you would put it upside down. In the mirror, I'm not upside down.
That's the reciprocal.
Oh, I see.
Good question. So let's take a look at a line. Is this a line? Is it? Does it have the characteristics of a line? Sure
Yes.
does. It sure is. This is a linear equation, right? This is a linear function. Now, if we draw this linear function, what would be my y-intercept?
3,
3 what? 3 bananas? 3 Bitcoin?
0, 3.
It would be 0, 3. Perfect. What's my slope?
2/1.
There you go. So I'm gonna go up 2 and I'm gonna run 1. So I end up here. And then I can draw. I could draw my linear equation, right? I'm gonna draw my linear equation. This would be 2x plus 3. It's my linear equation. But you're like, okay, professor, so what's up? So I'm like, well, this is you. You are that blue line. You are now going to look inside the mirror. You're like, what? What do you mean by it? What do you mean by that? Well, we're going to take the same problem. And the first thing you have to do is you have to change this to y. All right. F of x now becomes y. Then the second thing you're going to do is switch x and y. So now where y is, now you're going to have x. Where x is, now you're going to have y. You see what I just did? I'm going to label it here. These got switched out, right? Those are totally switched. Whenever you switch x's and y's, it's like you just crossed into the inverse world. That green line that I just drew here, that's your mirror. You're now into the reflection. You're now inside the mirror. You crossed. So now, what is the third thing you're going to do? Well, the third thing you're going to do is you're going to solve for y. How do you solve for y? Well, you're gonna subtract 3 here. So now you're gonna end up with x minus 3 is equal to 2y, right? Because these cancel out. And then, how do we get the y by itself?
Divide 2.
Divide by 2. So then we end up with y is equal to x minus 3 over 2, which is the same thing as saying what? X over 2 minus 3 over 2 is equal to y, right? Because they share the same denominator, right? And this is the same thing as saying 1 over 2 times x over 1 minus 3 over 2. Right? Because if I multiply 1 times x, I'm gonna get x. And if I multiply 2 times 1, I'm gonna get 2, right? So let me rewrite this. 1/2 x minus 3 over 2 is equal to y. So isn't this a linear equation? It sure is. What's my slope? My slope is what? 1/2. What's my y-intercept? What's my y-intercept? What's 3 divided by 2?
1.5.
That's right. So I'm gonna get 0 comma negative 150. 0 comma negative 150. So how do I draw that? Well, I'm gonna show you right now. I'm gonna go at my y-intercept, which is 0, negative 150. Right? So this is 1, this is 2, this is 150. And I have a positive slope of 1 over 2. So I'm gonna be here. So how do I draw that? How do I draw that? Well, I'm gonna draw it this way. I'm gonna draw it this way. This linear equation here, the 1/2 x minus 3 over 2 is equal to y. This is your inverse. And in order for us to rewrite it as the inverse, we put a -1 here. So this is 1/2 x minus 3 over 2. This is my bizarro. So now you're saying, well, hold on a minute. You just did 2 graphs, professor. You did the Superman graph here. Then you did all of this stuff in order to get the inverse. You got the inverse, and then you drew a second graph. How does that show us? How does that show us, professor, that this is bizarro? And where's Superman? Well, I'm glad you asked. Because if we put them together, if we put the first graph together, right? 2x plus 3, right? One, 2, 3, 1, 2. So this is 1 here. We're gonna put it in blue, right? Because this is Superman. And then the bizarro, I'm gonna put in red or purple. Let's put it in purple. So this is gonna be what? Negative 1.5. 1 over 2. So if I draw this, and you're like, hold on, okay, hold on a minute, professor. ¿Qué pasa aquí? What's going on here, right? Well, this is your Superman. And the one in purple is Bizarro. What's the equation for Bizarro? 1/2 x. 1/2 x minus 3 over 2, right? Is equal to f of x to the -1. Okay, but professor, you said there's a mirror. Where the hell is the mirror, professor? And I'm glad you asked. The mirror is right here in the orange. And that equation for the orange is y is equal to x. And what's y is equal to x? Y is equal to x is the identity line, right? So this identity line is your mirror. So when Superman looks at the mirror, on the other side is Bizarro. And Bizarro is the reflection. You guys see it? Do you guys see the screen or no? Hello?
I see the
Yes?
screen.
Yeah,
but
we see it,
it's
Professor.
it's hard to understand.
I got you. Practice makes perfect. I totally got you. So let me pause here. Hold on.
And then not only that, the midterm is what's gonna make us or break us.
Yeah. Basically.
Yeah. Yeah, guys, this is what it is to be in college. Yeah, it's hard. I know it. I feel you. That's why we have these great videos to look over and practice. So let's see what's going on with my iPad because it's freezing. Are you able to see my iPad or what do you see right now? Because it's
Yeah, we
freezing.
can see your cursor moving, the arrow.
Oh, you can?
Yeah, now you're scrolling up and down.
Woohoo! That's exciting. Okay, cool. All right. For some reason, my Zoom is not working. Uh-oh. My system is not working. All right, let's see. So if you could see my iPad, I'm gonna continue on my iPad because my Zoom, it looks like it froze. Hold on. Uno momento, por favore. Let's see if this is gonna help me. No. All right. All right, so you still see my iPad? Yes, I hope. You guys can hear me? No?
Yeah.
All right, cool. All right, so being that it's frozen, I'm going to be writing on here the what we need to go over for the review for the midterm. Review for midterm. So what are we going to review? We're going to review module 1. What's on module 1? Well, module 1 has a recording dated 8/31/2022 that goes over real numbers. You had a quiz on this. And that quiz, you had to know the difference between a real number, a whole number, an integer, a rational number. So you have to know those. We also have to know the orders of operation. Right? We also need to know what? Exponents. Radical properties were on the quiz. And anything I went over on this video on 8/31/2022. Module 2. We had a recording of 9/7/2022, which is on the Lumen site. And here we went over polynomials and interval notation. And what about polynomials? Well, we did addition, we did subtraction, we did division, we did multiplication, right? Of what? Of polynomials. We also spoke about the greatest common factor. We spoke about simplification. We did FOIL. We also introduced factoring. What about factoring? We have 2 terms. We have 3 terms. And we have 4 terms. What about these 4 terms? This is called grouping. We did those. Then for module 3, we had a recording for that. That was on 9/19/2022. And we continued with the factoring. Right? And here, especially in the homeworks, and this goes, by the way, for the homeworks for all of them, right? You got to look at the homeworks that relate to the video. The homeworks that relate to the video. The homeworks that relate to the video. So I know some of these homeworks, they have like these crazy physics problems, right? I'm not going to give you any of that. But I will ask you questions and everything that I did go over in the videos. And again, regarding the factoring, we had 2, 3, and 4 term grouping.
Can you show the module 2 when you're done?
Sure, no problem.
Okay.
Module 3, we did division of polynomials. We did simplification of polynomials. We did rational expressions. And what are rational expressions? Rational expressions are fancy fractions. And why are they called fancy fractions? Because they're going to have variables, right? So like x squared plus 2 or x to the 3rd plus 5, let's say. So those are rational expressions because they have variables, right? We also then here introduced lines. What about lines? We did slope. We did what? Linear equation. We did distance. We did midpoint. We did the difference between a vertical and a horizontal line. Then we did what the slope is of each. And you should all know what this is. Parallel and perpendicular, what the difference is between them. And the cool thing is there's videos to back this up. That's module 3. Module 4. We had multiple videos for module 4. 9/21/22, there was a video. 9/28/22, there was a video. 9/29/22, there was a video. And what did we go over on these videos? We went over lines. We went over quadrants. We did 2 points. And then from those 2 points, we got a line. We found slope. We found the midpoint. We found distance. Right? On 9/28, we went over parallel lines. More in depth, right? We did perpendicular. We also did quadratic formula. Quadratics, I should say. And we introduced parabolas. We did symmetry. And on the video on the 29th, we did functions and transformations. We did 1-to-1. We did domain. We did range. We did symmetry. Transformations. That was module 4. Module 5. We did quadratic equations. And these quadratic equations, I said, focus on finding roots. And I went over that on the video on 10.3. Hold on, module 6. On 10.3, we had a video. And I spoke about quadratic equations on 10.3. I did domain. And I did range. I did characteristics of functions on the video. And then that brings us to today, what we just finished, which is more transformations. And those included what? We did, this is today's video, right? 10, 12, 20, 22. We did x to the third, we did the square root of x, we did the absolute value of x, we did odd, neither, I'm sorry, we did even, odd, or neither. And we did linear inverse. And I understand on the homework, they go into the inverse of quadratics and parabolas, but again, only what I went over, linear inverse. All right. So altogether, you have 8 videos, which is the equivalent of about 8 hours of tutoring because I worked out the problems. I cannot ask you anything besides what's on these videos because the videos come off the videos come off the homeworks. So it's like they support each other. So let me go back to the gentleman that was saying go back to module, what was it? Module 4?
2.
Module 2. So let me present my screen because now I'm going to go from my iPad to the screen. 1 second. I guess my laptop needed to cool down because I was running too many screens at the same time. Okay. All right. So I hope everybody can see this. Oh no, I need to share my screen. Hold on. I hope everybody can see this. Yes. Everybody see it? Yes? No?
Yeah.
Okay, good. So everything that I just did on my iPad is basically these modules. So I'm going to break them down. I'm going to go to module 2 in a moment. I haven't forgotten. Okay, 6 and 7. So let's go again, one by one, module 1. So if you haven't done this already, this is how you got to start studying for your midterm. You look at module 1, you open this video up and you start looking at the video. You play the video and you say to yourself, okay, what did he go over? All right, so he went over sets. And by the way, I don't know if you guys know, you could go to settings, you could put playback speed, and you could put me on chipmunk mode, and I start talking like a chipmunk. And it goes 2x. And you start looking at what I'm going over. Everything that I went over on this video was on your quiz 1. Everything here. Now, intersection and union is also going to be on the midterm. Everything that's on these videos is on the midterm. So if you're looking for material to do problems from here, then you look at the video and you open these homeworks up. 1, 2, and 3. And you say to yourself, okay, did he go over this problem in the video? And the answer is yes. Did he go over this problem in the video? The answer is no. Did he go over this problem in the video? Yes. And I may have gotten over this problem with different numbers, but the concept is the same. Simplification, right? Simplification. Anything with decimals, I don't go over. Now, if you recall, I believe this problem was exactly on your quiz 1. This one right here. So that's how you study. And like, this is a repetition. Question 12 and 11 is a repetition of question 1. And then you go back to the video and you're like, okay, what else did he go over? Okay. Anything else? And then he went over exponents. All right. So where's the homework on exponents? Right here. Did he go over this problem? Very similar. Yes. Did he go over this problem? Yes. Did he go over this problem? Yes. Did he go over Langston? What's Langston to the 0?
1.
There you go. All right. Did he go over this problem? Yes. Did he go similar problems? Yes. Something like this? No. Something like this? No. 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 Definitely not this. Do not waste your time on this. I am not going to be asking you how far the distance is between here and the sun. This is not physics. Next. Radicals. I gave you a problem on radicals, and that was identifying the radical. Why did I ask that? Because I believe on this video, if I recall, I asked you about radicals. If it wasn't this video, it was the next. Maybe it was on the next one. Okay. And that was on your quiz. So now we get to module 2. Now, let me close these homeworks up, and you're going to do that for each and every module. You're going to open the video up. You're going to put play, and you're going to be like, okay, what did this guy go over? Interval notation. He did intersection. He did union. He did radicals. Yes, I did. Look, the radicals are right here. I actually gave you this problem on the quiz, right? What's the index? What's the radical sign? What's the radicand? Okay, it could come back. What are the parts of a polynomial? What's the parts of an algebraic expression? Then, just like I did in module 1, you open the homework up. You open the homework up. And you say, okay, what did he go over on that video? Did he talk about the parts of the polynomial? Yes, he did. Did he talk about subtracting, multiplying, adding, and dividing? Yes. Did he talk about simplifying? Yes, he did that. What else? Let's go back to the video. What else did I go about here? Oh, look, addition, subtraction, multiplication. I try to reinforce the ideas from the homework. I cannot make, like, I'm not going to be giving you trigonometry on this test because did I teach it? No, I didn't. Greatest common factor. Right here, greatest common factor. So I'm on module 2. What's your specific question on module 2? Hello? You asked me to be on module 2. Hello?
Oh,
Are you there?
yes. Yeah, I'm still here.
Yeah. So do you see how you're going to focus yourself on module 2 and module 1 and all the other modules? You're going to listen to the video, or you're going to try and see what I went over on these videos. These videos are here because this is your tutoring. It's so hard to get a tutor. So why am I gonna give you stuff that I didn't go over? There's plenty of material right here. Module 3, rational expressions. Open the video up. Put play. And then I tell you, what are we gonna be going over today? Polynomials and factoring, boom. And then it shows you what I did with the polynomials, more subtraction, more multiplication, more division. Then we do factoring. And then you open again the homeworks. So you open homework 3, homework 3A, homework 3B. You open them up. So this is 3. You open 3A. Oops. Open 3B. So in 3A, this is division. This problem could show up on the midterm because actually, no, this will not show up on the midterm, and I'll tell you right now, because this jumps degrees. It goes from degree 6 to degree 3. I'm not gonna do that to you guys. So if I'm gonna give you a problem, I'm gonna give you something like this. This is fair. Because this is going 2, 1, 0, which is fine. So this is good. All right. Let's see. What else? That's too long. I'm not gonna give you this. This is fair. Too long. Too long. These are too long. I'm not giving too long. So if you go back to the video and we're doing the division, oh, this is factoring. I think this is the oh, right here, you see? 3n plus 2, and you got 12n plus 3 plus 11n squared plus 5n minus 8. So this is a pretty long problem because this has 4 terms. But I did the whole thing. It's right there. I could give that same exact problem, and shame on you if you don't know how to do it, because literally I'm giving you the answer. Literally I'm showing you how to do the work, right? And then we went into factoring, right? 2 terms, 3 terms, 4 terms. And I gave examples of grouping. I gave examples of what 3 terms would look like. I am not going to give you anything that I have not gone on these videos, have not gone over. 2 terms, difference of squares, difference of cubes. And I even go on the video and say, this is the only time that this may occur. If the number is divisible by itself 3 times, that's for difference of cubes. If difference of square, it has to be divisible twice, like a 49 or an 81 or a 16. A 27 is more like a cubic, right? Because it's 3 times 3 times 3 times 3, right? Or 8, 2 times 2 times 2, right? So stuff like that. So you got plenty of review here, plenty of review. This video here is like an hour and 10 minutes. Look, I spent all of this time. I even color coded it for you guys. I mean, there's no reason why you can't pass the midterm because everything is here. All right, so this is module 3. So let's go to module 4. Module 4 has 3 videos because I should have put one of these videos in module 5, but I put them all here. It doesn't mean that we did all 3 videos for this section. So you have 3 videos here. So you look at this one. Let's look at the lines. So this is the video that I introduced lines. Is there a homework on lines? Yeah, homework 4 has lines right here. Let's open it up. So this is the homework on lines. And I'm going to go to the video and you're going to say, okay, well, he starts off with factoring, which is like a continuation of what he did on the previous video. But the meat and the potatoes for this video is going to be the lines, right? So here are the lines. It starts at minute 25 for 9:21. And then I introduce the quadrants, right? You need to understand where in which quadrant X and Y are positive or negative or positive and negative. What's the difference between the x-axis and the y-axis? What is the slope of a horizontal line? I even write it there, 0 slope. What's the slope of a vertical line? Undefined. How to find slope? Y2 minus y1 over x2 minus x1. You need to know the equation. I'm not going to give these equations to you. You need to know them. You need to know the midpoint. You need to know distance. I did 2 points. Expect on your midterm 2 points. From those 2 points, find distance. From those 2 points, find midpoint. From those 2 points, find slope. From those 2 points, find the linear equation. Everything I did here on this video, you are responsible. And I told you this when I was teaching. I said, guys, I'm going over all of this, not because I'm wasting my time here, is because this is going to come back. And I zoom in. Oh, what's the difference between here? Oh, this is a negative slope. It's going down. See, negative slope. I even zoomed in. Then I gave examples of the city. What's the difference between 2 parallel lines? Do they have the same slope? Do they? Do they have the same slope, 2 parallel lines? The answer is yes, they do. What's the difference between a perpendicular line? A perpendicular line crosses another line and it forms a 90-degree triangle. 90-degree, not a 90-degree triangle, a 90 degrees. They form 90 degrees. So right here, 57th Street crosses Park Avenue and First, I don't know, I can't zoom here. And then that would be the negative reciprocal. So if the slope for Park Avenue and Fifth Avenue, let's say, is 2 and they're parallel, then the street, let's say 57th Street or 59th, is going to have the negative reciprocal, which is negative 1/2. And then I say, well, what happens if I have 3 here for slope? Then this would be negative 1/3. You always do the negative reciprocal. So here's the video. And then we went into solving equations of one linear equation. So that's 921. And that had to do with lines. So let's look at the homework. Solve for the equation. We did this problem. Solve for the equation. Solve for the equation. All these are linear equations. Solve for the equation. Solve for the. I'm not giving you decimals. Don't be wasting your time on decimals. I'm not giving you decimals. Anything crazy, like something like this, no, forget about that. You understand? No crazy stuff. Remember, you only got 2 hours. So I have to condense concepts into the problems. So now let's
I
look
have a
at,
question.
sure, go ahead.
How many questions are in the midterm?
It's a good question because, like, for instance, this linear equation here can have 10 parts. This linear equation right here, it can be 1 question, 10 parts. So you start off with 2 points. Find me the slope. That's the first question. Find me the linear equation. That's the second question. Find me the midpoint. That's the third question. Find me the distance. That's the fourth question. Find me the x-intercept. That's the 5th question. Find me the y-intercept. That's the 6th question. Is it parallel? Is it perpendicular? Right? That could be 7 or 8, right? So that one question has 8 parts. Or I could just give you one question, you know, for like off topic. You're like, this is a vertical line. What's the slope? There is no doing any math for that. You have to know what the slope of a vertical line is. What's the slope of a vertical line? All of you should be saying it right now.
Rise over run.
What is the slope of a vertical line? What is this?
over change in x?
The
It
slope of
doesn't
slope-
exist.
It does not exist. Undefined. What is the slope of the ocean right here, 2 blocks away from my house? Because I live 2 blocks away from the ocean. If I go to the boardwalk and I look at the ocean, what is the slope of that horizontal line over the horizon? Tell me, what's the slope of a horizontal line?
1.
0.
0, 0, 0, sorry.
0. And this is what this video is about, 928. And I tell you, what is the slope of a vertical line? What is the slope of a horizontal line? Again, guys, I am not here to break you. I am here to ask you questions on these videos. There's no surprises here. No one in this class is gonna say to me after the midterm, oh, you didn't teach us that, professor. You know, you crazy, man. Why you give us this crazy question? You didn't teach us trigonometry. That's never gonna happen. Because I'm actually gonna look at the videos and I'm gonna take out the problems. Literally. So shame on you if you don't look at the videos. Because that's how I'm gonna go. And then I'm gonna go to the homework. I'm like, how can I change this problem so it looks a little different, but it's still asking the same thing? Right here, butterflies. Like if you look at this video and you see butterflies, it doesn't mean, you know, you have vertigo. It means that I'm trying to teach you symmetry. What type of symmetry? Y symmetry. Because what you have on the left, you got on the right. There's a reason why I use these examples so you guys don't forget. And this is the Freedom Tower. And then I start describing here. This has Y symmetry. Or like the asking the problems in the homework, it has vertical symmetry. And then here I start introducing the different functions, x squared, right? If we look at the homework that's for this one, oh, is it the next one? Is it module 5? Oh, this is quadratic equations. So we went over x squared, right? On the function. This is the video for 928. So now we go to the video on 929. This is that Thursday that we were following a Monday schedule. And then I start here talking about one-to-one. And how do I test whether something is a function or not? How do I test if a graph is a function? What kind of test do I do so it doesn't cheat on its x? You guys remember?
The vertical line.
Vertical line test. And how do I test if the graph has a one-to-one relationship? What kind of test do I do? Is it going to be a vertical or a horizontal for the one-to-one?
Vertical line.
It's going to be a horizontal for the one-to-one, but for the function, it's going to be a vertical. Right? What happens if the x values repeat in a set? Is that a function? No, it is not, because you can't cheat with your x. Remember that. You can't cheat with your x. So if your x shows up more than once on that set that has multiple points, you're a cheater. That means it's not a function. I went over that in the videos. So here, for the functions and I'm sorry, someone had a question?
Oh, no.
So here on the videos, we started off with the parabola and I explained here domain and range. Then we expanded it and I said, okay, well, domain is the train, range is the elevator, up and down, domain is left and right. And I think right here at this point, I think I said, oh, Mr. Langston, you know, we could put points here on the table and then we could draw this, but we don't have to be exact. We just need to approximate. And then I introduced the other ones, x to the third, square root of x. See, look, x to the third. But here they were not moving. They were not, I was just telling you, the function could move. It could go to the left or it could go to the right, but right now we're not moving them. I'm just introducing them to you so you know what they look like. And I said, this looks like the Statue of Liberty or a spaghetti. Then I said x square root of x. Then I did the Michael Phelps, the absolute value. All of this is valid on the midterm. So if I give you a bunch of graphs that have not moved and I tell you, identify them and give me the names, you better give me cubic function. You better give me a cubic root. You better give me absolute value. You better give me identity line. You better give me parabola. Because this is why I take you to the zoo, so you can understand which one it is. There's a difference between a giraffe and an elephant. Remember, they're both mammals. All of these are functions, but oh boy, do they look very different. Then I start introducing the vertex form of the equation for the parabola. That's what causes the parabola to move to the left, to the right, up and down. What happens if there's a negative in front of the function? It reflects over the x-axis, right? What's the value for h? You always take the opposite value. What's the value for k? You take whatever that value is. So if k is negative, well, guess what? K is going to be negative. But if h is negative, then you're going to get the opposite value. You're going to get a positive value. And I went over all of this in this video. All of it. All right. All right. So then module 5. Here, the video is not here. I believe it's in module 6 for, no, module 6 here, this one, module 6.7. This is where quadratics, I start talking about quadratics here. On 10.3, I go over module 5. And I believe there was a student in the class and she's like, and she sent me pictures. I even got a picture of a cat. And the student was like, yo, even the cat is confused with this quadratic formula. Like, help, what the hell's going on? And then I focused on this problem, question 3. And I said, well, we need to factor this out and test whether or not, like, I'm not going to give you stuff like this. I'm not going to give you question 5 and 6. Forget about it. That's not going to happen. But I do expect you to be able to factor x squared minus 17x plus 66, a similar problem to this, and tell me whether or not those factors will make this equal to 0. I believe it was 11 and 6, negative 11 and negative 6. And if you make that equal to 0, it becomes positive 11 and positive 6. There you go. See, positive 6, positive 11. And that was on the video on 10.3. So if we go to 10.3, which is module 6, 6.7, I should say, right here, 6.7. On this video, we put play and I start going over the values right there, see? And then after I did this, I went into domain and range. And I said, in order for us to find the domain, we got to make it equal to 0 if we're giving an algebraic expression. And I did that as well. Let's see. And then I believe this was homework 6 I went over. Yep, right here. All right, here, domain and range. And we went over these problems and in the video. And I told you, if you're given a set like this and these points, what's the domain? And you all should say, if you're given these sets, if you're given the set with a bunch of points and you're asked what's the range, the answer should
Hey,
be
Google, wait off.
all the y values. And domain would be all the x values. You see? 15, 22, 23, 39, 43, 50. Those are your domains. Range, y values. Remember? Everything I tell you. So that's what's on this video. And we went over all of this. Literally, everything's here. Everything is here. Everything is here. Now see, look, right there. See, domain and range. And I started, okay. So if this is blah, 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 I could just hear myself talking on this video, even though I can't hear myself. And then I said, in order for us, and then we went over this graph. Yeah. Now remember, I'm going to ask questions that relate to whatever I did. So if I'm going to ask domain and range, I'm going to ask domain and range from a graph, right? I'm going to ask you from a graph. Or if I give you a graph, then I ask you, what is the domain and the range of the graph? Or I can say, the following equation, x plus 2 squared minus 2, right? Graph it, which I did in one of those videos. And then from after you graph it, I'm going to say, what's the domain and the range? What's the vertex? What's the axis of symmetry? What's the symmetry? What type of symmetry does it have? And we did all of that in the videos. All of that we did. And you're gonna be responsible for that. All right, I cannot give you more than 15 problems if they're long. If they're long problems, I cannot give you more than 15 because it's 8 minutes per question. 15 times 8 is 120 minutes. There's just no way. If they're short questions, then I can give you more than 15. If it's true and false, you've seen true and false tests. There could be like 100 questions for 2 hours. True and false, true. Literally, people are just going TF, 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 FT, FT. Sometimes they're just guessing. All right, let me look at my chat because I haven't looked at my chat. Was it saying, good evening, professor? Medea is laughing. And then she's saying, sorry. Okay, I don't know what that means, but okay. So guys, it looks hard, but it isn't because I did all the hard stuff for you already. You just got to look at the videos, which you should have been already doing. And you should be working out the problems that we did on the video. If you do that, and you've been doing the homework, you're going to pass. There's no reason why you shouldn't pass. All right, I'm going to stop recording this.